Welcome to the Introductory to HIRA course for plumbers, that is Hazard Identification and Risk Assessment. In this course, we will look at 6 modules, starting with the fundamentals of risk management, moving over to risk identification, risk evaluation, risk control, applying risk management principles, and finally, risk transfer. Let us start off with the fundamentals of risk management. The purpose of a risk assessment is to ensure, firstly, that the most up-to-date information about the level of health and safety risk posed to a person is available. Secondly, it is to inform the risk manager, the risk assessment team, and all employees of the necessary protocols and measures to be taken to prevent and mitigate the potential risks and hazards faced when working within an environment that may expose them to the dangers as stated within the risk assessment. Let us start off with a few definitions of words or phrases that you will come across during these 3 courses. Hazard means a source of or exposure to danger. Hazard identification means the identification and documenting of existing or expected hazards to the health and safety of persons, which are normally associated with a type of work being executed. In our first definition, we express that a hazard means a source of or exposure to danger. It is noteworthy to remember and to keep in mind that a source of potential harm to people, facilities, the environment, or the community that leads to unwanted damage is the definition of hazard. Now, understanding a hazard includes the nature, magnitude, and potential consequences, as well as relevant target or impact characteristics, potential timeframes, pathways or mechanisms of its manifestation, and residual harm. Also, understanding sources of harm to the community may require recognition of incentives. A risk is a combination of the likelihood of an occurrence of a hazardous event or exposure and the severity of the impact. This could be injury, illness, or environmental impact that may be caused by the event or exposure. Risk assessment means a program to determine any risk associated with any hazard at a site in order to identify the steps needed to be taken to remove, reduce, or control such hazard. Reasonably practicable means practicable having regard to the 4 following things: the severity and scope of the hazard or risk concerned, the state of knowledge reasonably available concerning that hazard or risk, and any means of removing or mitigating that hazard or risk, the availability and suitability of means to remove or mitigate that hazard or risk, and finally, the cost of removing or mitigating that hazard or risk in relation to the benefits deriving therefrom. Risk management. The risk assessment procedure that we will discuss forms part of the integrated risk management approach applied to the works performed by an employer. Sound and effective environmental health and safety risk management is a leading practice and a means of improving the performance objectives of the works going forward. Conducting a risk assessment is a legal requirement in terms of the OHSS Act. The results of the risk assessment are to be made available to all interested parties and employees of your company, including any person who may be affected by the risks as stated below in the risk assessment. ALAR, or as low as reasonably practicable, the concept of weighing the risk against the sacrifice needed, and to implement the measures necessary to avoid the risk. In health and safety, it is assumed that the measure should be implemented unless it can be shown that the sacrifice is grossly disproportionate to the benefit. Consequence or severity. This is the outcome of an event or situation expressed qualitatively or quantitatively, whether a loss, injury, health or environment impact, or disadvantage, or a benefit, gain or advantage. Control or barrier. Control or barrier is defined as anything used to control, prevent, or impede energy flows or the loss of control of a hazard. Types of barriers include physical, equipment design, warning devices, procedures, work processes, knowledge and skills, and supervision. Controls impact on the risk of the event, whether it is an opportunity or threat. It is essential to consider controls or barriers in terms of their order of greatest effectiveness. This order is known as the hierarchy of controls. Critical controls. Those controls that significantly influence the likelihood and/or consequence of an event. If removed, they will significantly impact the risk rating. Event is an incident or situation which occurs in a particular place during a particular interval of time. Events involve release or manifestations of or exposures to the hazard. Events can be wanted, opportunity, or unwanted, threat. Probability or likelihood is the probability or chance that an event will occur. Risk analysis is a systematic process to understand the nature of and deduce the level of risk. There are many different methodologies of conducting risk assessments. In the following 3 courses, you will be taught on how to do a risk assessment that is carried out in accordance with leading practice for health and safety risk management. This is a qualitative risk methodology. It will be followed utilizing a risk assessment and control document as a risk assessment template. A risk determination matrix will be used for the evaluation of risks. The following is the risk determined matrix we will use. It is represented here by a 5x5 risk matrix. Remember earlier we spoke about the definition of risk being the combination of the likelihood or probability of the occurrence of the event, as well as the severity of the impact. In other words, how likely is the event to occur, and what sort of impact or severity will it have on an individual's safety, health, or perhaps even the environment or community around us. As you can see on the left-hand side, point number 1 would range the severity from insignificant to catastrophic. On the top right is the probability or likelihood that an event will occur. When determining the low, medium, or high rating of a risk, here represented by green, yellow or amber, and red, we will then determine whether the risk and hazards that are attached to those risks for the task that we are performing is going to be a low risk, a medium risk, or a high risk. And this is how we classify or quantitatively define the risk that is attached to our scope of work. Now, insignificant could be a near miss or something that could have happened to impact a person's health, a person's safety, or even the environment around us. And it is something that we must remember, that when we classify our risks or the hazards that we are going to be exposed to, we need to understand that one risk might have to be split into 3. Well, what do we mean by that? Well, for instance, if a plumber was digging a trench and that trench needed to be dug in order to put waste pipe in as for a brand new building. You see, the trench itself is going to offer specific hazards to an individual. First of all, we will look at the safety risks or the safety hazards concerned therein. For one, we are going to be digging an excavation, which means there is a huge possibility of engulfment. In other words, the trench collapsing on top of the individual, which could cause suffocation, it could cause serious injuries, it could even result in the death. That is a safety-related risk, a very high risk when it comes to digging excavations or working inside an excavation. Now, this could be categorized as a major risk. Why not catastrophic? Well, catastrophic could be multiple deaths. In this case, you might just have one person working in and around that environment, which could cause their death. This would be major, one death, one serious incident. Catastrophic would be multiple deaths or multiple serious injuries. Well, in this case, when we are digging the trench, there are other known hazards, such as health hazards, dust control, or perhaps if the ground itself could expose us to some sort of chemical, some sort of agent that could impact our health. It might not be as serious as somebody dying because there's no engulfment possibilities when it comes to a health impact. There's no falling into it because that's not a health impact. We are looking at it specifically from somebody having a health impact. So on one line of our risk assessment, we might quantitatively take a look at the likelihood of a major catastrophic incident occurring. This could be a level 4 on our severity index, and the likelihood of this could happen either once a day, once a month, or a few times per year. Now, you will notice when it comes to any type of excavation work, you are going to look at a high risk immediately. It's going to range from a 12, a 16, or a 20 guaranteed. And that is because of the high likelihood of dangerous working occurrences, dangerous situations always occurring during trenches or excavations. Now, that is your pure risk. That is the initial risk. Later on, we will then take a look at how we control that. And that comes down to our point number 3, the effectiveness of controls. Now, you cannot remove all risks and you cannot always avoid the hazard. In fact, you will never normally get to 100% control measure. But what we can do is take a look at replacing, substituting, transferring, or impacting the type of hazard or the type of risk that we are facing to lower the probability or lower the severity. Now, how do we do that? Well, for you as plumbers, you know that when you dig a trench or dig an excavation, you have to have adequate shoring. You have to ensure that it is braced inside so that there is no possibility of the engulfment actually occurring. In that case, you have removed, eliminated, or terminated one part of the danger of an excavation. There are other dangers within the excavation that could also pose a health or safety risk, such as climbing down the ladder and falling into the excavation from the ladder, depending on the height of the excavation that you're in. Now, you might need to try and substitute or transfer or replace. Perhaps you can't do that and you need to isolate the hazard or impact it using engineering controls. Well, this could be using a safety harness. You see, that's an engineered control. It's something designed to protect the person after a fall. But it's not as effective as eliminating a fall altogether by saying that you are not allowed to work at heights at all. Well, that would be impossible, because as soon as you dig a trench, there's ultimately the possibility of falling into that trench, even when using a ladder. And so it is very specific to sites, specific to tasks, specific to even the actual trench or work or any type of thing, work scope that you are actually performing. And that is why we cannot do generic risk assessments. You cannot rely on a templated document that you received from a safety consultant to kind of cover over all risks. And that is because even though you are performing the same task you did yesterday, the impact, the severity, the probability or likelihood may be different on the day. It may even be different for the exact same type of work. That is why we have to perform a risk assessment. Now again, we come back to the health aspect. When we dig a trench, there is a health aspect, but not as severe. You see, you might just have a bit of an obstruction of the throat, or inhale a little bit of dust, or get a bit of dust inside of your eyes. That would bring it down to almost a minor health impact. So how would you then stop that from still being minor? In fact, you could say to yourself, because it's minor, it's not bad. Well, let's take a look if it was minor, but it happened every single day. You'll notice that it goes from 2 all the way across to 10, because we have an almost certain chance of getting dust in our eyes while doing excavation work. This means it is a medium risk, or here, quantitatively produced as an item 10 on our risk matrix. And since it's in that yellow or amber section, it is a medium risk. So just having the dust in the environment could cause a minor incident, but the probability creates a medium risk. Now, how do we prevent this from happening? Well, notice if you brought it down to being an insignificant event, saying, well, it's not going to be a first aid incident, it's just going to be a little bit of a nuisance to the person, and you drop that down to 5. Notice that the 5 is still within your medium risk range. It's not low yet. Now, we read a definition of ALARP, or as low as reasonably practicable. In other words, we want to try and get every single risk, every hazard that is going to expose ourselves or others to danger, to as low as reasonably practicable. What does reasonably practicable mean? Well, taking into consideration those 4 things. What knowledge or information is available for me as an employer to identify how to protect my employees? Is there a possibility that I'm currently using a level 3 or 60% effectiveness of control within my hierarchy of controls, and there is actually information out there that proves that I could have an 80% impact or 80% effectiveness of my control, because there is a possibility of transferring or impacting the hazard in a specific way. So we don't thumb suck. We are not saying this is what happened in the past and this is definitely what's going to happen in the future. No, we are saying that you must keep up to date with what is currently happening, what is reasonably available, and how you as an employer or even an employee impacting the risk around you is going to effectively try to reduce the risk and hazard that you or others may be exposed to. Now, we also don't want to forget the environment. Obviously, there's going to be an impact on the environment for anything that we do, especially as plumbers working with different types of hazardous chemical substances, working with sewers, you're working with water. That is an environmental thing, and so we don't want to waste water, we don't want to pollute water, and we also don't want to abuse the water around us, because it is such a beautiful resource, one that is eventually going to run out if we do not look after it properly. And so you might have a catastrophic risk, such as polluting the water, but the chances of that is very unlikely. Notice where your risk lies. It is still a medium risk. Even though it is very unlikely, because there is a possibility for it to be a catastrophic event, we are still sitting within a very medium risk. So ALARP, or as low as reasonably practicable, would mean we want to try and get it down to the green area, but it is not always possible. What we do know is it is possible to take the time out and identify if there is any possibility of ensuring that our employees, even ourselves and anyone else, including the environment, is kept safe from the work that we perform. So this is the risk determination matrix that we will use. We will use the effectiveness of controls as seen below, ranging from 0 controls or 0% to personal protective equipment only being 20% of a control. Administrative controls, such as ensuring that you have documentation, training, and other types of administration in place, which is only a 40% control. Coming up to where it starts making it a little bit safer is you're isolating the hazard. You're impacting it by engineering controls, bringing you a 60%. Then getting to a lot safer, replacing, substituting, or transferring the hazard, making it even safer for the employees that are performing that task. And if at all possible, can you remove, eliminate, terminate, or avoid the hazard or impact altogether? So let us take a look at the hierarchy of control or effectiveness of controls in a little bit more detail. Hierarchy of controls or effectiveness of controls. The addition of control effectiveness consideration to the basic risk assessment controls provided an opportunity to further discuss each control as well as the sum of all controls for an unwanted event. Now, there are many ways to establish control effectiveness, ranging in complexity from simple to very complex. A relatively simple method called the Control Effectiveness Rating, or CER, has been developed to generate and record subjective ratings of controls based on 2 dimensions. This is the control type as well as the control quality. Now, the control type is based on the hierarchy of controls. The control quality offers a percentage of choices for control reliability and availability. This method of combining those 2 dimensions will be discussed. So the control type in the risk assessment is indicated by those colors, the green, yellow, and red. And this gives the general effectiveness of that control, where green is good quality or a very effective control, and yellow and red are obviously less adequate. However, we still want to have that control quality. What is the percentage of control that we are getting? So even though we have an initial risk control, in other words, we brought it down to a green or yellow, is it as low as reasonably practicable? You see, we might be effectively producing a low risk, but then only controlling it with personal protective equipment. We only control it by 20%. So even though we look at the control type, because it's green, we are happy. It's green means go, and so you think it's a low risk. But when we look at the percentage choices, and we notice that the percentage is only ranging to 20% because we are only putting PPE onto it, we then say there is a better quality of control. What is that quality? Increasing the percentage of effectiveness. By gaining a 40% increase in effectiveness, you will then administer admin controls, training, safe working procedures, risk management, supervisory training. All of this is going to effectively control it. Now, we always want to look at both dimensions. We don't just want to look at the green, yellow, and red. We always want to look at, in the previous slide, the effectiveness of controls by the percentage, or how well we are doing to control the risk that we are facing. Within the hierarchy of control, we can eliminate the hazard. That is the complete elimination of the hazard by design. We can substitute or minimize the hazard by replacing the hazard, the material or process, with a less hazardous one, or significantly reducing the magnitude of the hazard or material so consequences are greatly reduced. You can engineer it so that you design in controls or redesign the equipment or work process in order to lower the hazard. You can isolate or separate the risk, placing a physical barrier on the hazard by guarding or enclosing it completely. You can administrate the risk by providing controls such as training and procedures. And finally, you can use appropriately and properly fitted PPE where other controls are not practical. Now, we understand that PPE is mandatory, and we always want to protect people with personal protective equipment. But notice that the effectiveness on this control, even though it is the last control in terms of hierarchy, we always want to ensure that the PPE that we use is both appropriate for the task being performed and properly fitted to the individual. So it's important to know that risk management is a management function with the objective of protecting people, assets, environment, and income by avoiding or minimizing the potential for loss from pure risk and the provision of funds to recover losses. So the purpose of every plan is to facilitate the attainment of an organization's objectives, which is outlined within their mission and goal statement or their Occupational Health and Safety policy. Safety is a goal which every organization should strive to achieve. Where does it start? With management. So, as managers wanting to ensure effective risk management, you must focus on pure risk. A pure risk is a risk which results in loss, damage, disruption, or injury. Pure risk can usually be insured. However, risk management is primarily concerned with pure risk. What is the difference? Well, risks are classified as pure risks or speculative risks. A pure risk are examples of loss or damage resulting from fire, environmental impairment, occupational incidents, disease, natural disasters, crime, business interruption, product liability, contract liability, or business information. Speculative risks, on the other hand, are examples of uncertainty relating to new products, new production processes, changing of supply resources, new trade restrictions, or new market conditions. So management, the first thing you want to do to effectively control risk is to plan. The organization must plan in order to reach its safety, health, and environmental protection goals. To summarize the importance of planning, let us list some of the main contributions. Gives direction to an organization. It promotes cooperation between departments and people inside an organization. It forces managers to look towards the future for modern technology. It emphasizes interdependence of various functions to achieve common objectives. And it encourages proactive management of change. There are always benefits to planning for occupational health and safety. Some of these benefits increase worker efficiency. It improves flexibility of people and processes. It reduces costs. It reduces risk in operational and maintenance activities. And it can help achieve effective environmental controls. Planning always starts with formulating the goal you want to achieve. So here are a few questions you should ask yourself. What is the objective of the plan? What would it mean to the organization as a whole? What results should be achieved and what results should be avoided? What resources are needed? What restrictions need to be considered? And how do we foster commitment? Senior executive staff makes it clear that they attach the same importance to such a risk prevention and control program as to any other organizational objectives. Only then will it be possible to have an effective program of risk management. The second step to execute a plan is organizing. Management needs to organize resources and activities by assigning responsibility and authority. This is done by determining an organizational structure or organogram, clarifying responsibilities, establishing accountability, establishing clear channels of communication, allocating resources meaningfully, promoting cooperation. Remember, when individuals work together to produce a whole that is greater than the sum of the parts. And then finally, dividing the total workload into activities. The importance given to health and safety management is reflected in the position of health and safety staff in the management structure. Now, equally important is the quality of the health and safety staff and how they are perceived. At all levels of health and safety staff, they still serve a staff function. So please remember, you, she staff, you must earn recognition and respect. Organizational relationships must be created to clarify to employees who will assign their tasks to them and whom they must report to. Responsibility and authority must be delegated to people. Authority to do the job means that they will have the authority to deploy resources to perform the task. Now, the term authority is used to distinguish between line and staff authority. In complex organizations, the distinction between these two functions is not very clear. So, employees often find that their recommendations are rejected. It is therefore important for management to decide what type of authority will be granted to a staff member. This could be the advisory capacity, a compulsory advice, concurrent authority, or command authority. The following is now going to be examples of each type of staff function and different types of authority. Advisory. This could be a line manager who can choose whether they want to consult the human resource department on the academic qualifications required for a health and safety officer. Compulsory is the manager will be obligated to consult the human resource department on academic qualifications for safety officers. Concurrent is that the manager and the staff manager must agree on the qualifications for health and safety officers. And finally, command. The safety managers will give orders on safety matters that other departments will have to carry out. To reduce levels of conflict which may arise between line and staff managers, activities should be properly integrated. Now, responsibility and authority should be clearly demarcated. Firstly, management considers the plan. Second, analyze primary task in detail. Third, subdivide the primary task into subtasks. Fourth, combine tasks into departments. And lastly, implement coordination mechanisms. The third step in risk management is leadership. Now, leadership is one of the most controversial subjects in management. Leadership involves taking the lead in formulation of plans, influencing people, giving orders, motivating and managing people, managing conflict, and communicating with subordinates. Leadership is the activity that combines energy into the enterprise. It should happen in such a way that employees willingly pursue the objectives and goals of the organization. Now, through leadership, we activate members and resources to get things into motion and keep them in motion. The final step in risk management is control. When an individual has control over certain activities, they can influence the course of events. Control is the process where management ensures that the activities of the organization fit in with objectives and planned activities. Until actual performance is compared with the standards required, management will not know whether activities have been carried out according to plan, nor will they be able to identify weaknesses. So control in the safety system is a very important phase. It is a continuous process which is interlinked with planning. Performance in terms of safety must be regularly measured and compared against standards. The knowledge, experience, information, and facts acquired during the control process are the most important inputs in the next cycle of planning. What is the link between planning and control? Well, it is a cycle of continual improvement. You see, when you plan by setting standards and then you control them by measuring them, you can then plan again to correct any actions or standards. You then control it by checking performance. It then moves back to setting additional standards, higher standards, or the same standards, and then measuring them again. Once you've measured, you correct any necessities, and then you check on performance. This continual cycle will help you to effectively manage your risk.